Welcome back to the... get out of there, please. Thank you. There's always something, isn't there? Welcome back to episode 29 of How to Do Stuff with Mr. Stevenson. And today we're talking volume of rectangular prisms. What is volume? We've already talked about rectangular prisms, so we have that down pretty well. What we haven't talked about yet is volume. So what is volume? Well, I'm going to show you. Come with me. So I'm going to show you how volume works, what volume is all about. Volume is basically how much space a rectangular prism, well, a volume is for any three-dimensional shape, but we're studying rectangular prisms. So volume is how many cubes of a certain size you can fit inside or this box. I could use any size box, but I want to fit them in here, and I'm going to put them in. I'm just going to start dropping them in. So I'm using dice all about the same size. These are cubes, still rectangular prisms, but cubes have all the same size. Am I too close? How about that? Okay, so it's finding out how many of these cubes you can fit inside of a space. So I'm going to start dropping these in. Like this. So I'm putting all the dice inside the box. I'm going to kind of get them in there, and then I'll show you inside here so they're all lined up neatly. Okay, and the nice thing about this box is it just so happens that it fits all my dice almost perfectly, as you can see inside there. Okay, now I can figure out the volume of this thing by counting the dice. Hold on, 3, 2, 1. There, got it. Okay. There's my rectangular prism, so I can count them. And I have 6 on the bottom. And I have 1, 2, 3, 4, 5, 6, 7 rows of 6. So if I have 7 rows of 6, that means that the volume of this box is 42 cubic units. Each dice is 1 cubic unit, whatever the measurement is. They aren't probably the size, they aren't probably 1 inch, but they're probably about a half inch. But we'll call them units since we don't know what they are. So how many of these cubes can you fit inside of a rectangular prism? So now that you've seen a little bit of an example of how volume works, I want to show you a quick little simulation here. I have the net of, we'll call it the pizza box. It's a rectangular prism, but it's a folded down pizza box, okay? So another example of how rectangular prisms work and how volume works is basically how many cubes can you fit inside the box. Okay, so this would take quite a while if I'm going to keep adding cubes until it's full. And so if we look at the flaps of the box, like if you fold this thing all up so it's a pizza box, how many units high is it? It is 3 units high. If you see right here, when I fold this thing up, it'll be 3 units high. Okay, now I can add all of my layers here, and I have to be 3 high. And there would be, if I folded this box up, this is the size it would be. If we counted it, it would be 3 high by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Looks like 18. And so I have a length of 18. This is the height, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12 by 18 by 3. So we have 3 total dimensions, length, width, and height. Whereas area was only 2 dimensions. It was length and width, or base times height. It was just the 2. Volume is the 3 dimensions. So you have your base, or your length, your width, and your height. I can show you what that looks like right here. So I have a really good example of this right here, and here's your basic cube. And there is a formula for finding a volume of a rectangular prism. that would be, sorry, I think my cat is meowing at me. Go away. Sorry. So we're going to use this formula. Just like with area, we use the formula for rectangles. We use base times height. For triangles, we use base times height divided by 2. Or 1/2 the base times height. In this case, volume formula is just length times width times height. That's it. So in this case, the volume of that cube right there basically means how many small cubes, how many ones, and this one's measured in centimeters. So it's basically you're looking for how many centimeter size cubes can you put in, meaning if a dice was 1 centimeter by 1 centimeter by 1 centimeter on all sides, how many of those dice could you fit inside here? So we do that. Pretty simple. According to me, I think it's pretty simple. I'm going to take the length. The volume is the length, which is 5, times the width, which is 5. And this is a cube, so times the height, which is 5. And if I multiply that first, 5 times 5 is 25. And what is 25 times 5? That equals 125. Okay, here's the tricky part. Don't mess this up. Instead of being centimeters squared, what is it going to be? Did you say centimeters cubed? That's right, because we're measuring in cubes. We're measuring how many cubes fit inside the object. So this cube will fit 125 1 centimeter cubes inside of it. Okay, let's bring on the next example here. I have another rectangular prism shaped like this. Not a cube anymore, but we're still looking for how many cubes we can fit inside there. These again are measured in centimeters. So we're going to call them how many 1 centimeter cubes fit inside this thing. If you can imagine the box I used, it's similar to this one, except mine was standing upright. And this one's kind of the long side of the base. So we do the same thing. We use the formula. The basic formula is volume equals length times width times height. So I'm going to take the length, which is right down here. That's 12. I have the width, which is 4, and the height, which is 5. So I'm going to go 12 times 4 times 5. And what's 12 times 4? That's 48. And what's 48 times 5? Well, I can do this quickly. I'm going to multiply 40 times 5, and I get 200. And I'm going to multiply 8 times 5, and I get 40. So 200 plus 40 equals 240, say it with me now, centimeters cubed. Yep, we're transitioning to the cube sign now. Be careful with that. And I have one last one. This big scary one right here. Now this one has fractional edge lengths, but don't be intimidated by that. I'm sure some of you, mostly in the audience that sees these videos right now, has experienced multiplying fractions, because once again, let's get our formula back up there. Length times width times height. Okay, the length will be 2, the width is 1/3, and the height is 3/4. So let's do 2 times 1/3 times 3/4. Now I can multiply in any order I want. That's called commutative property. I'll come back to that some other time, but in the commutative property, I can multiply these first. So if you guys go back to the olden days where you guys were working on fractions, it would look something like this. You would go 1/3 times 3/4, and you just multiply across, right? You'd go, that's 3. I'm going to redo that 3. That's really sinfully ugly. And you know I like nice handwriting. 3/12. Okay. So then I have 2 times 3/12. And when I multiply that, I just put 2 over 1, and I get 6 over 12. And if you simplify that, you would get 1/2. 1/2. And that one doesn't have any measurements on it, so we're just going to say units cubed. And that would be the volume of that thing. So, that's it this time. That's it. That's volume of rectangular prisms. No big deal. As usual, if you have questions, call me. Or call him. Up to you. I probably would be a bigger help at this point.